Hi, my name is Teresia from Universitas Ciputra, Surabaya, Indonesia. Today I'm going to present our research titled Integrated Framework for Incorporating Sustainability Design in Software Engineering Lifecycle. This paper was published in the Information and Software Technology or IST journal in 2021. And this is the outline for today's presentation. Sustainability have been actively studied in decades. United Nations defines sustainability as the development that meets the needs of the present without compromising the ability of the future generation to meet their own. In short, we need to endure the current capacity to fulfill the future need. Sustainability development concerned with three main sustainability dimensions, which is social, economical, and environmental. To achieve sustainable environment, we need to consider the entire dimension. It means meeting the human needs with the ecological constraint using economic to achieve sustainability. For easier understanding of the goal, we can divide the goal based on dimension. From here, we can know that to achieve economical sustainability, you should achieve some aspect of environment and also social. Therefore, to do sustainability development, we require a long-term and joined-up thinking. Unfortunately, the current practice of software engineering rarely considers sustainability concern. There is a lack of long-term thinking. The consideration beyond immediate software product quality is usually treated as a secondary concern. The software engineer tends to focus more on the technical dimension. We know even though the technical dimension is the main concern of the engineer, it is strongly depend with business and also organizational context, which are the part of economical and also social dimension. Ignoring sustainability concern can result in various damage. The visible impact of the current technology is the increase of software disposal. This is the common problem in our software engineering practice because we update the system and the hardware that can be obsolete. Another obvious impact is the high energy consumption because most of the technology focus on the high performance system which required high power consumption. There are various works that have been proposed in software sustainability in the last decade. The work started with the proposition of the green soft in the early 2011, and many of the work focused on requirements engineering process for software sustainability. And several works also propose a conceptual idea on addressing sustainability on the entire system. However, there is still currently inadequate awareness within software engineering community. By understanding the state of the art in software sustainability research, we found there are several problems with the current studies. First, there is no agreed definition of what software sustainability means and how it can be measured or demonstrated. It is because sustainability is not well understood within software engineering community, and it makes the effort of addressing sustainability concept remain ineffective and inefficient. There is also a lack of practical guideline to address sustainability design in software engineering practice. Most of the work only focus on the conceptual level, and without the methodological support, sustainability is hard to measure. Another problem in addressing sustainability in software engineering practice is the limited quantifiable method that supports software sustainability evaluation. It is not clearly inferred how the current technologies support the improvement of sustainability in software system. Another significant problem is there is no standard measurement to evaluate software sustainability, and the current practices rely heavily on the participant experience to evaluate the sustainability achievement. Therefore, In our integrated framework, we built a framework for designing a sustainable software. Our proposed framework consists three main components. The first part is intended to determine the sustainability requirements from the entire sustainability dimension. We propose the goal meta model, which will also link it with the other software quality attributes as sustainability characteristics. From the defined goal model, we identify the required behavior to achieve sustainability goal using the proposed scenario meta models. From the action flow, we identify the possible feature that required to build a sustainable software. By using the listed feature, we decompose the functional implementation based on the proposed meta model that consists of reference, attributes, and constraint. This feature meta model is useful for mapping the scenario and the computational code that is used in the software sustainability evaluation. We propose a semantic program analysis to gather the evidence and examine it to determine the sustainability achievement. In order to collect those artifacts, there are four main phases in our proposed framework. The first phase is intended to determine the sustainability requirement. The goal is to develop methodology that define the quality attributes model which satisfy the entire sustainability dimension. In the second phase, the feature composition is made based on the proposed meta model that is include task, feature, and the set of classes. The feature from the task defined in the scenario meta model are decomposed as the functional implementation. This feature meta model is useful for mapping the scenario and the computational code that is used in the third phase, which is sustainability evaluation task construction. In this part, we ask the domain expert to define the baseline based on the defined sustainability metrics and indicator. And in the last phase, we aim to evaluate the developed software against the sustainability metrics. The achievement metric is generated to present the evaluation result based on the sustainability baseline. For the running example, we use a system of home automation that is targeted to address elderly people challenge such as the limitation of mobility, visual, and also hearing problem. The system should provide an intelligent service to support and assist the elderly people so that they can stay in their home environment while being medically treated. Therefore, the system should be able to detect and alert user condition to health emergencies. When there is an emergency, the system should be able to notify the medical facility and the selected family member. Moreover, the system should provide a security control system where user can set in-house security mechanism and remote security mechanism. And the system should provide a mechanism to allow the user to send emergency alert when they feel threatened. The result of the requirement development phase is presented as the sustainability goal, requirements, and scenario. We can use needs that can be defined in the different sustainability dimension. For example, in individual dimension, the system should provide daily living capability that can be fulfilled with medical facility notification and the activity context detection activity. The behavior of each activity you describe using scenario. One of the tasks is automated emergency detection. This action flow describes what is the task. The next, the software design result in next, the software design result is presented as a feature list and software class based on the action flow. The feature described with its attributes, constraint, and reference. To analyze the impact of the proposed approach, the comparison with the traditional software engineering approach is conducted. The empirical experiment aims to answer the research question based on the corresponding hypothesis. The purpose of feasibility study is to assess to what extent the applicability of insure can address sustainability concerns in different domain applications. Participants were selected through closed requirement process based on our criteria. First, all participants should have at least 3 years software engineering experience. And second, all participants should have background in engineering field. Third, we prefer to select participants with sustainability or software engineering background. And we also conducted a replicated study. And the purpose of this study is to address the generalization threats from the proposed approach. Therefore, this study aims to evaluate the practicality of insurance in natural context. The participants were selected based on the same criteria, which are the software engineering experience, sustainability knowledge, and the familiarity with the smart house and healthcare system. The participants from industry came from the different background, such as automotive industry and financial industry, power and energy industry, and IT consultant company. They also came from different occupations such as software developer, software analyst, and business process analyst. The different characteristic from the participant is in feasibility study and the replicated study were found during the analysis process. In terms of software engineering experiments, the participant in replicated study have more knowledge and experiences. Meanwhile, the participants in the feasibility studies are superior in terms of sustainability knowledge and the familiarity with the domain application. And here are some results of our study. The first, we can see that our proposed approach can address sustainability design, which means it can precisely define the stakeholder and the requirement in each sustainability dimension based on the stakeholder needs. We also extract more stakeholder requirements and features using our proposed approach. And based on the evaluation result, we can see that the engineer have more ability to select the alternative, and it can also reduce the time in analyzing the conflict between requirements and minimizing the negative impact of software system in sustainability dimension. However, there are some challenge in addressing sustainability design. We found that the risk analysis step is still too difficult without any guideline from the researcher. And it's also impossible to have a system with no conflict or no negative impact in sustainability dimension. Therefore, there are still some conflict, but we can minimize the negative impact by the sustainability score. And another result is about the sustainability achievement evaluation. The evaluation results show that the proposed framework is capable to identify more metrics and sustainability dimension coverage. And we also see that from the both studies, we can present precisely the value of each matrix and indicator. And using the evaluation result, we can see that the method is capable to indicate which specific scenario should be redesigned to improve the sustainability achievement. However, we also face some challenge in this study. Participant has to analyze the scenario manually and perform the code mapping. We also have some difficulty in some security scenario that cannot be tested in the healthcare domain because of the limitation in metrics and the measurement. We can see that our proposed approach is intended to enhance the engineering ability to determine the software sustainability requirements and to evaluate the achievement itself. We can provide a systematic framework that can guide the software engineer in addressing sustainability concerns. In terms of evaluation itself, we can see that there is a significant contribution in extracting software sustainability related stakeholder requirements and also feature. with the proposed meta model. And we also can see based on our empirical study that we can reduce some amount of time to perform the software engineering test by considering sustainability concern. However, there are still some limitation in our work. For in the future work, the research should include the developing of the fully automated tools that can help the engineer to easily incorporate sustainability concept. We also need to explore the sustainability criteria that is related with the security attributes. That's all of our talk today. Thank you for your attention.